Hi, my name is Brett Corville, and this is my major research presentation on GPS and GIS and how they're used in Google Earth. What is GPS? GPS stands for Global Positioning System. GPS is a network of orbiting satellites that send precise details of their position in space back to Earth. The signals are obtained by GPS receivers such as navigation devices and are used to calculate the exact position, speed, and time at the vehicle's location. What is GIS? GIS stands for Geographic Information System. GIS is a computer system designed to capture, store, check, and display data relating to positions on Earth's surface. GIS can show many different kinds of data on one map. This enables people to more easily see, analyze, and understand patterns and relationships. History of the two programs. The very first GPS system was developed in the 1960s to allow ships in the U.S. Navy to navigate the oceans more accurately. The first system had 5 satellites and allowed ships to check their locations once every hour. GPS is well known for its military uses and was first developed by the U.S. to aid in its global intelligence efforts at the height of the Cold War. GIS. The year 1960 saw the development of the world's first true operational GIS in Ottawa, Ontario, Canada, by the Federal Department of Forestry and Rural Development. Developed by Dr. Roger Tomlinson, it was called the Canada Geographic Information System and was used to store, analyze, and manipulate data collected for the Canada Land Inventory, an effort to determine the land capability for rural Canada by mapping information about soils, agriculture, recreation, wildlife, waterfowl, forestry, and land use. How does GPS work? GPS units locate specific points based on a place's latitude and longitude. This is a short clip on how GPS is used.
At over 20,000 kilometers above sea level is a constellation of satellites, each orbiting Earth every 11 hours and 58 minutes. These satellites are continuously beaming data down to us on Earth, which is in turn received by devices such as your phone or navigational units in your cars, allowing you to see where you are on the planet. There are a lot of misconceptions about how GPSs actually work, an example being that your phone and the GPS satellites are both talking to each other. So let's get down to it. How do GPSs work? GPS stands for Global Positioning System, which works through trilateration, not triangulation or multilateration, which is commonly misconceived. There are many different types of navigational satellite systems from countries across the world, but the most popular and commonly used system is Navstar, which is the USA system. There are, however, Russian, Indian, Chinese, and European equivalent systems, although the Indian and Chinese systems sit in a geosynchronous orbit above their countries, which means they are not worldwide systems. The Navstar system, which is simply referred to as GPS, is what we will be focusing more on, although most phones and devices tend to have the capabilities to use both GPS and GLONASS. GPS satellites are set up in such a way that from almost anywhere on the surface of Earth, you should have a direct line of sight of at least 4 GPS satellites. This is quite important on the basis that GPS point positioning requires at least 4 satellites to calculate 3 position coordinates and the clock deviation. As GPS units are receivers, there needs to be something sending some sort of signal to devices such as your phone to receive. Each GPS satellite broadcasts a navigational message towards Earth which contains an extremely accurate timestamp, which is obtained through an atomic clock which is on board these satellites. And the satellites also broadcast their position at the time of broadcast, with all GPS signals broadcasting at 1.5752 GHz and 1.2276 GHz. These 2 bits of information allow you to work out your position on Earth. With these satellites all sending exceptionally accurate time down to Earth, your phone or GPS receiver can compare the difference of time between when the signal was sent to when it was received to work out the distance between you and the satellite. By multiplying this time difference with the speed of light, as the signal is sent at the speed of light, you can begin to get the distance away you are from that satellite. As these satellites are also sending whereabouts they are, you can begin to draw spheres around the satellites, with you being somewhere on the outer border of that sphere. As we introduce more GPS satellites into the mix, we begin to get closer to where we are. By calculating the time differences between these satellites, we move from having no idea where we are to being able to pinpoint where we are typically down to 5 to 10 meters on average, with the potential error being around 15 meters.
How does GIS work? GIS can use any information that includes location. The location can be expressed in many different ways, such as latitude and longitude, address, or zip code. Many different types of information can be compared and contrasted using GIS. The system can include data about people, such as population, income, or education level. It can include information about the land, such as locations of streams, different kinds of vegetation, and different kinds of soil. It can include information about the sites of factories, farms, and schools, or storm drains, roads, and electric power lines. Devices that use GPS and GIS. GPS. Cell phones, cars, smartwatches, and there's several more that could be on this list. GIS. GPS devices, Google Earth, and geotagging. There's also others that can be added to this list. What is Google Earth? Google Earth is a geo browser that accesses satellite and aerial imagery, ocean bathymetry, and other geographic data over the internet to represent the Earth as a three-dimensional globe. Here is a web page that talks more about Google Earth. On this web page, I have highlighted more of the important information about Google Earth. Like I said already, Google Earth is a geo browser that accesses satellite and aerial imagery, ocean bathymetry, and other geographic data over the internet to represent the Earth as a three-dimensional globe. Google Earth is available on the web for free, or you can purchase it. The free version is intended for home and personal use. This product has many features, including displaying satellite and aerial imagery, a growing set of layers of mappable data, the ability to display third-party data, tools for creating new data, and the ability to import GPS. The Pro version, this version is developed for commercial use, ads, movie making, as well as importing ESRI shape files and map info tab files. It can measure areas of circles and polygons, and can print and save high resolution images. Enterprise form. This product makes imagery and other geospatial data available to employees within organizations such as corporations. Each of these versions of Google Earth can be used to read and create data in KML format, which enables educators, students, and other users to share data. It is available for several operating systems such as Microsoft Windows 2000, Microsoft Windows XP, Microsoft Windows Vista, Mac OS X version 10.3.9 or higher, Linux, or FreeBSD. If you didn't already know, there is even a version of Google Earth for your iPhone. This is the second page of the same web browser, and this is about becoming familiar with Google Earth. In order for students and educators to use Google Earth effectively, they need to learn the basic functions of the user interface. The Student Google Earth User Guide is designed to help users become familiar with Google Earth's most commonly used functions, offers links to more detailed information. The Google Earth tip sheet is a one-page summary of some of the most frequent used Google Earth functions. A great deal of third-party data is available on the web that can be displayed in 3D Viewer. Perhaps one of the richest and most varied repository of this data is Google Earth Community Forums. Each forum is a collection of discussion threads devoted to a particular broad subject area. Some examples of forums that are specifically focused on education include students, educators, and tools forums. The Google Earth education community offers a site where educators and students can share information on topics that can be explored in Google Earth. Many of these submissions include KMZ data. How does GPS and GIS work with Google Earth? Google Earth uses both GPS and GIS in its program. GPS is used when people are looking up different locations in the world. GIS is used in Google Earth when people find a location and pull up data or post new data about that location. Classroom uses for GPS and GIS. I myself am going to be a social studies teacher, and these are some of the ways that I will use GPS and GIS and Google Earth in my classroom. I can use Google Earth to find historical locations such as battlefields, settlements, cemeteries. It can be used to help students learn latitude and longitude. It can be used to explore demographic information for countries of the world, and it can be used to explore natural change over time. I have a link to other ways of how you can use Google Earth in your classroom. Here is a Google Maps education website, and it gives you some purposes for Google Earth and how you can use them in the classroom. For math, you can utilize real world math. You could use a ruler to calculate distance and various units of measurements, or you can find the angle of elevation for hiking trails or ski runs. For history, you could use historical imagery to travel back in time and view your neighborhood, hometown, and other familiar places to see that have changed. You can learn more about U.S. presidents, their birthplaces, and the progression of the states that voted during elections. You can view the many historical maps from David Rumsey, map collection like Lewis and Clark Trail. Science, you can explore the Earth's many biomes and habitats on all the continents. Explore the rich resources from the Science Education Resource Center to help facilitate better understanding of the Earth's many systems. You can explore underwater terrain, visit sea vents, and learn about the health of the ocean. And that is the end of my presentation. I hope you enjoyed.